So something shows up on the DCA that I want you to be prepared for, even though it's unlikely to show up on the STAR test. You're given a description of an equation like this, and instead of matching it to an equation, you're asked to match it to a model. So we're going to do a couple of examples to help you out. The first one here, 1/3 of x less 7. If you were to write that with an equation, it would look like this. 1/3 of x less 7 equals 4 more than 2x. This part is going to feel a little bit backwards. There's two ways you could do it. I'll try and do it without backwards. 4 more than 2x. Now maybe that's pretty easy, but if you needed to do that as a model, this term right here might be hard to write, so I'm going to show you what it would look like. Here is my x term, but because it's 1/3 of x, I'm going to divide it into 3 parts. And then maybe lightly shade in that part to show that I only want 1/3 of the x. Minus 7 would just rely on these squares like you are already familiar, but because it's negative, those would be shaded as well. So the shading is kind of taken on 2 different meanings here. Maybe this one wouldn't be shaded, maybe this would be one full solid box, but then it would still be broken into thirds. And then equals 4 plus 2x. Well, that's pretty easy for the 4 and for the 2x. There's the plus 4, and then for the 2x, there's 2 full bars, not broken down into thirds. So 2x, positive 4, negative 7, and 1/3 x, each corresponding to part of the statement given in the beginning. So here's another one. 1/4 of a number plus 2 is the same as 3 times a number minus 5. So the challenge is going to be in the 1/4 of a number when we write that with the model. So we'll do maybe a solid line here to show that this part is solid, but then we'll break the rest of it into fourths. So this x term has been broken into 4 pieces, and we're only using one of them. 1/4 of a number plus 2 is, we'll just put a couple of unit boxes, is the same as, that's an equal sign, 3 times a number minus 5. And 3 times a number is simple, I think, because we just use 1 bar for each of the a number or the unknown part. And the minus 5 individually shaded units. So this model, this sentence, and the mathematical equation all have direct connections. Here we have 1/4 of an entire x. So we have 1/4 x plus 2 is equal to 1, 2, 3x, 3 times a number, minus 5. 1, 2, 3, 4, 5. So it's this convention to write a fractional x value that I wanted to acquaint you with. And I will make the effort to show that in class on Monday as well. We will review on Tuesday. The test is Wednesday.